Okay, a quick review session here. Square roots. Remember, square root is the reverse of squaring. We know that for A, you can consider 9 times 9 equals 81. We are going to reverse that. The square root of 81 is equal to the square root of 9 times 9, or 9. So you can pull out pairs of them, is one way of looking at it. B, negative square root of 9 equals the negative square root of 3 times 3, or negative 3. Part C, square root of 1 is 1, square root of 25 is 5. Keep that simple, right? Now be careful when we get to D. Quite often we want to take the square root of 36 into a 6, and square root of 64 is 8, and add those together. You can't do that. You have to add two numbers together. Square root of 36 plus 64 equals the square root of 100, which equals 10. Remember, we had 6 and 8. That would have been 14. We would have had the wrong answer, wouldn't we? But E now is the square root of 36 plus the square root of 64. These are two different problems. That is 6 plus 8, which is 14. All right, sometimes these don't work out quite as nicely as you want. Square root of 75 is not a perfect square. However, we know that that is 3 times 25, which is 5 times 5, right? So we have the square root of 3 times 5 times 5. If you pull out the pairs, you end up with 5 square root of 3. When you are multiplying, it is as if, in part B here, it was the square root of 5x times 10x. 5x times 5 times 2x, if you want to break those up into factors. Notice that I've got a couple of 5's that will come out and a couple of x's that will come out. That becomes 5x square root of 2, because the 2 is the only thing left without a partner. All right, we've already seen this a little bit. Part A, we can simply just take the square root of 25 and the square root of 16 is 4 and leave it like that. Leave your fractions as improper fractions. That's okay. For part B, treat this still like it's all under one radical. 2 goes into 150 75 times. X goes into x cubed, x squared times, still under the radical. Again, remember the square root of 3 times 25 times x squared. That was your 5 times 5. So the 5 comes out, the x comes out, the square root of 3 stays in. We can add as long as they are like radicals. 8 plus 9 is 17 square root of 13 for part A. These are like radicals. They can't be simplified. So 1 minus 20 is negative 19 square root of 17x. Unfortunately, sometimes we don't have like radicals. However, this can be 9 times 3. That's a perfect square. So if that's still under the radical, right, A becomes 5 times 3 square root of 3 plus 4 times 3. There's your perfect square. You could break it down into more factors, 2 times 2, and pull out the pairs. But this becomes 2 square root of 3. So we have 10 root 3 plus 2 root 3 becomes 12 root 3. This happens to be 6 square root of 2 times 9x minus 4 square root of 2 times 4x. Those are perfect squares. Those will come out. So that's 6 times 3 square root of 2x minus 4 times 2 square root of 2x. 18 root 2x minus 8 root 2x gives me 10 square root of 2x. All right, heading into factoring. Now all that was just to get to the point where we can factor and deal with quadratics. If you remember, we taught you a number of methods for factoring. I'm going to try and go through them quickly. First one is, if there is no constant at the end, just factor out the common factor, 3x, x minus 3 equals 0. That means x is either equal to 0 from there, or x is equal to 3 from here. Over here, 2x squared plus x minus 1. You need everything over to the left side, set it equal to 0. Now I have a constant on the right. So we're looking at factors of 2 times negative 1, or negative 2, that add up to 1. Well, factors of 2 are just 2 and 1, or 1 and 2. So 2 and 1, the question is, for this term here to be positive, right, the larger number has to be positive. The smaller number is going to be negative in order for this to be negative. For this to be negative, 1 is positive, 1 is negative. So now we're going to go ahead and group and factor, right? So we're going to rewrite this in terms of these numbers. 2x squared plus 2x minus 1x minus 1 equals 0. This will allow me to group and factor. Pull out the 2x, leaves an x plus 1. Factor out a minus 1, leaves an x plus 1. Regroup and pull out the x plus 1. Notice that when I pull out the x plus 1, those are now gone, right? Those were pulled out. What's left? A 2x minus 1 equals 0. You set those both equal to 0, and you find out that x is equal to negative 1 or positive 1/2, coming from here, and this one from here. All right, square root property. So in order to use the square root, we've got to isolate the square. So I'm going to add 21 to both sides. I'm going to get 3x squared equals 21. I'm going to now divide by 3. I get x squared equals 7. Now I can go ahead and take the square root of both sides. The square root of x squared is x. When you take the square root, you've got to consider both plus or minus the square root of 7. That's not a perfect square, so it stays as is. That was part A. Part B, we can go ahead and take the square root because the square is isolated already, and I have x plus 5 equals plus or minus the square root of 11. We're going to subtract 5 so we can get the x by itself. X is equal to negative 5 plus or minus the square root of 11. Solve by using the quadratic, by completing the square. This is one we don't like to use all the time, but it's a valuable tool. If you remember, we're going to take the negative 1 to the other side, so we got x squared plus 4x plus something equals positive 1. Remember, I added 1 and added 1 here. Okay. Completing the square asks us to take half the middle term and square it. Half the middle term squared happens to be 4. If this middle term was 12, we take half that and square it, and we get plus 36 here. Okay, so half the middle term squared. Now remember, when I add 4 here, I've also got to add 4 here, and what I've done is I've created a perfect square. This here is x plus 2 quantity squared. Now I can go back to our previous slide and say, oh, I can take the square root of this, which gives us x plus 2 equals plus or minus root 5. And then we can subtract 2 and subtract 2. X is equal to negative 2 plus or minus the square root of 5. Quadratic formula, remember x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. If this is in ax squared plus bx plus c equals 0 form, right, which it is. So we're going to go ahead and plug that in. X is equal to negative b, negative 2, plus or minus the square root of 4 minus 4 times 2 times negative 1, all over 2 times 2. Okay, I went ahead and skipped a couple steps here. You can go back and look at them if you need to, but here's where it gets a little tricky. Sometimes when we cancel, we only cancel out of one number. Remember, it's got to come out of both those terms. We can pull a 2 out. And if you want, just go ahead and pull the 2 out. So negative 1 plus or minus root 3 all over 4. Now I can see that the 2's will cancel, and I'm left with x is equal to negative 1 plus or minus the square root of 3 all over 2. Take a good look at that if you're having trouble with that, and that's the lesson for today.